Housing 2.0 Thought Leader webinar. Now we're right in the middle of Community Health Improvement Week. And you know one way to improve community health? Have people live in high performance homes. Now today we're going to explore value engineering, zero energy ready at lowest cost. Now we have someone with us today that has both site building and off-site construction experience. Our guest is Scott Sanders, Director of Construction for Kinexx Modular in Chicago. Scott started building high-performance, energy-efficient infill homes in 2013, hoping to find a balance between his experience with large production home builders and small nonprofit organizations. Now, prior to joining the Kinexx team in 2022, Scott worked for two national production home builders, a nonprofit weatherization organization, and he ran his own building company for almost 10 years. And in that process, he earned 5 Housing Innovation Awards from the Department of Energy, and he built some of the most affordably efficient homes in the Chicago area. Now, you know who else cares about community health? Our sponsors. The first is Schneider Electric, who is driving the digital transformation of modern homes with smart and sustainable energy solutions for ultimate comfort and energy efficiency. Their connected home ecosystem of smart energy management solutions provides digital control of energy use throughout a home, from the grid via their smart electrical panel to their connected wiring devices. This grid-to-plug solution makes it significantly easier to create smart, solar power and backup power-ready homes, both now and in the future. Next, we have Panasonic Healthy Indoor Living Solutions. You know, they're helping builders across the country differentiate themselves with powerful, code-compliant, and cost-effective indoor air quality solutions that provide a safer environment for home buyers. Jinko Solar is a leading PV module manufacturer and energy storage system integrator. The company has deployed more than 100 gigawatts of their Eagle modules in 160 countries globally, including more than 17 gigawatts right here in the United States. Eagle Storage brings together the best energy storage technology for turnkey hardware and energy storage services. Eagle is a trusted choice for U.S. solar and storage projects. And our newest sponsor, LG HVAC. As a leading proponent of the electrification movement, LG is proud to pave the way with arguably the broadest portfolio of home electrification products, from air-to-air and air-to-water heat pumps for HVAC, water heaters, clothes dryers, and washer-dryer combos, to advanced energy storage systems, EV chargers, and super-efficient appliances, including the industry's first Energy Star certified induction cooktop. LG's innovation and technology will help us promote decarbonization and collectively create a better life for all. Now, during the course of today's presentation, you can submit questions for Scott. Simply use the questions box inside the GoToWebinar control panel. I'm going to review those questions and pose them to Scott after his presentation. Scott, welcome to the webinar series.
All right. Thank you very much, Mike. I appreciate it. You have jumped off there, and you've given me the reins here on the screen. I've set a timer in the background for myself for about 45 minutes here. I have a number of slides to go through, mostly with pictures. Don't worry, not a lot of text, not a lot of words. And we're going to sort of walk through building high-performance homes theoretically at a cost-effective way. So I'm going to get right into it. And as Mike said, if you have any questions along the way, put them into the comment box. Mike, if you would interrupt, feel free to interrupt me if a comment is pertinent. Otherwise, we can take a bunch of questions down at the end, and I can continue on well beyond 45 minutes to answer everything and resolve anything else that comes up. So let's jump right into it. This presentation, I have given similar presentations for many years, and it saddens me a little bit that I still have to give these presentations, that the whole building industry just magically isn't building high-performance homes cost-effectively. We are a very fractured group and a very fractured industry with 100,000 home builders building 100,000 different ways across the country. Our country itself, right, is segmented in climate zones, and so what might work for builders in Florida does not work for builders in Minnesota or in Alaska or Hawaii or wherever it might be. And so with those asterisks, I want to mention these sort of caveats at the very beginning here, and I'll come back to these at the end too to wrap things up. But anything that I talk about here in this presentation and in these slides and these pictures, it is not a recipe for how to do this. This is the intent of this presentation is to share ideas and to share with you what has worked for me in Climate Zone 5 around Chicago, the Chicago metro area, and really any other area that has that specific climate zone when it comes to installation strategies or mechanical strategies. But there's a lot of other things in here that deal with optimal value engineering framing or advanced framing or thoughtful foundation design or window shading or all kinds of things that are applicable to all climate zones, and certainly not just the climate zone 5 outside of the Chicago area. So again, don't take this as a recipe, but take this in and sort of use it as osmosis, I guess, to merge it together with what you have going on in your specific market, with your specific clients, with your specific building experience for wherever you are along the experience level in building. These apply to single family homes, this applies to multifamily, this applies to light commercial, stick frame and metal frame. A lot of different building assemblies can roll into these ideas here. Second thing here out of these 4 that I want to make sure you walk away from this presentation with after 45 minutes is that proper planning prevents poor performance. And normally this is not used in the context of building performance, right, and energy performance or in building envelope performance, but it absolutely does mean that here as well. Failure to properly plan leads to terrible building envelopes, and terrible building envelopes leads to unhappy customers who are either really, really hot or really, really cold when they don't have to be. So please properly plan and get high performance buildings. And we'll talk about how to do that throughout these next slides. Next takeaway really is that off-the-shelf materials and detailed assemblies work really, really well when done properly. Again, follow the instructions, use care when doing these things and installing these products, and magically the building performs really, really well. If you take the most advanced, fully adhered house wrap or weather-resistant barrier and you put it on your house upside down, or you forget to flash the windows or whatever, you have this amazing product that you spent a lot of money on that works terribly because you installed it wrong, right? Sounds super simple, but sometimes people forget that, and especially subcontractors, no offense, sometimes seem to forget that as well. Finally, and sort of the main takeaway is that the cost-benefit trade-off is there and is really applicable to your market and what you're building with your subcontractors and with your materials. So again, I'm not trying to tell you how to build, but I'm trying to give you some examples of how to think about building, which might help you build better, higher performing, more energy efficient homes. And it might reduce your costs, but it might bring you to cost parity with conventional construction, even though it's higher performance. So think through that as we're going through. Generally, the presentation that we'll talk about, again, over the next 40 minutes or so is broken down into these 6 segments. I'll talk a little bit about me so you know that I have some credibility to talk about this kind of stuff. We'll talk a little bit about plans and specifications and how to develop those and design of homes and buildings. We'll talk just a little bit about budget and finance and cost and building materials that are in there. We'll talk about Kaizen philosophy of Kaizen, continuous improvement, and process along the way. And then finally, we'll wrap it up after that 45 minutes with discussions and questions. I know I'm trying to cram 10 pounds into a 5-gallon hat or whatever the phrase is, but we're going to work to get all this in here and answer anything I don't at the end. So my building background overall, as Mike had said, I've been building homes, single family and multifamily homes for almost 20 years now, I think. I did start off with some production home builders doing cookie cutter tract housing. And then once my heart healed from doing that, I transitioned into doing some semi-custom and custom homes for clients outside of the Chicago metro area. And that's where we had a lot of housing innovation going on. We were, as Mike said, 5-time Housing Innovation Award winners, building infill, single family, new construction homes along the way. I've also, this is my multifamily tract housing experience out when I first started building in project management. I've also done panelized construction. Mike had alluded to me doing some off-site construction, which is true. It first started with panelized construction. So I did a couple of homes next to each other where we stick framed one, we panelized one, and we panelized one with a different manufacturer to try to understand the speed of construction for the same model over and over again, and the efficiency with either materials or with cost for stick frame versus panelized, again, on the same product. And then did a little bit of multifamily construction as well. And then, as Mike said, now my current position is the director of construction at Kinexx Modular in Chicago. So we are an off-site manufacturing home company that is based in the city of Chicago itself. And we are building also, again, new construction infill single-family homes out of modules. And so these are not mobile homes, right? And I know Brandon Weiss was on 2 weeks ago talking about Dell and their methods of building. I won't go a lot into modular unless there's a lot of Q&A around it. But right now we are building modules in a factory. And as you can see on the right side of the screen here, taking those out to site and fitting them in some really tiny places sometimes when it comes down to actually making measurements. Right there, we're erecting modules in a very congested area next to a church in between two existing 3-story buildings. So they get into some tight places sometimes. All right, so that's enough of my background. Hopefully I've gotten some credibility with you, that you'll trust me when I talk about some of these things and believe my experience in saying, hey, you should think about and you should try this. So first of all, let's start at the beginning, right? Because we have to start at the beginning, talking about specifications, design, and planning, right? So we need to know where the goalposts are for what we're designing to if we're going to design a high-performance building. And for the purpose of this presentation, we're talking about building zero energy ready is the key word there, homes that comply with the latest guidelines for the DOE program. So at the beginning of 2024, January 1st, 2024, the DOE's energy ready home requirements went into version 2, revision 1, as you can see in the middle of the screen here. California has a little bit different, and then multifamily is another section down below this. But the point of having this slide up is not for you to memorize this or take a screenshot, because this is available on the Zero Energy Ready Home website. It's just to say, what are we designing for? What are we trying to get to? Is it code compliance? Is it Energy Star? Is it Zero Energy Ready? Is it Passive House and FIAS? Is it Living Building Challenge? Is it LEED certification? What are we doing and how are we doing it? So we know what to back into our plans, our design, our building envelopes, and our assemblies. So because we're building to Zero Energy Ready, we have a very specific checklist that we're following, right? The radar checklist. And we've always found that it helps when we're doing either a prototype set of plans, if it's a home that we're going to build over and over again, or if it's a one-off custom home, that we're still following this checklist probably 2 or 3 times over the course of the project. Of course, we're doing this checklist at the end, or our rater is doing this checklist, but we're also doing this checklist just before we begin construction to make sure that our final architectural approved plans still comply with all these things. And we've figured in all these things, and we've procured all of the equipment that we need to comply with this. And then typically we're also doing it in our pre-design phase with a client, if we have a custom client or semi-custom client, to say, here's what we're trying to match up to, here's the checklist, and here's why we need to do these things. In case you want an imported Italian marble for your countertops, we might have to have some flexibility on that because we need to go with triple pane windows, or we need to go with a higher performance mechanical system or something. So we've always found that starting with the end in mind, beginning with the end in mind, right? That's a Stephen Covey, 7 Habits of Highly Effective People, I think, is always great with client relationships as well, to unify the design team with the architect, the builder, the homeowner, and say, this is what we're shooting for, and we're all aligned to get there. And here's the goalpost, like I said. Very beginning, not starting with design, but I guess I would say the next step along the way is a site visit for us, whether or not it's a multifamily project or an infill project, like I showed with that crane and the modules being set, or a suburban lot like this that just happens to be passed over for one reason or another. We always want to understand where we're building, what the exposures are, what the terrain is here, what the tree cover is for solar exposure, what the views are for neighboring windows, if it's leading out onto a back patio or porch, or if we have bedrooms that are, looking in on a pool or something like that, just to make sure that we're beginning the design and setting the expectations with clients from the very beginning properly. So once we do that site walk, we bring up to clients and we talk through with clients things like this. So this is siting for a house. Right now we are looking north, and so this picture is of the south elevation of a house. And I've got this is not a home that I've built, but a home that is in the area that I'd stop to take a picture of. But I've got to compliment the builder on having overhangs for their house. It's great, and you can see how effective overhangs are in the middle of summer. Whether or not it was luck or design, the overhangs just hit the bottom of that double hung window that's in the center of the house there, and they completely shade the 2 windows that are to the left of it in this picture. So in the winter, of course, the sun is lower in the sky, and so They're going to get much more natural light in through these windows in the winter when it's probably desirable instead of in the middle of the summer. So that's great. Also great is that the tree cover, there's no trees that are shading this roof if they wanted to put solar on the roof. But the drawback here is that they have 1, 2, 3, 4, 5, 6, 7, 8 penetrations on the south side of their roof assembly. And this goes back to planning for us and for any design lesson. If you are planning with solar in mind, which is part of the Zero Energy Ready Home program, is to try to make sure that all of your roof penetrations where possible are on the not south-facing side of your roof, presuming that you were designing with south-facing solar in mind. And so for us, that looks like this. So for our homes, again, south here is to the left. This is a sunset going off to the west there. But all of our pipe penetrations for both our radon vents and our main plumbing stack come out through the north slope of the roof, so we can amass as much solar on the south sides of the roofs as possible. And then any of our bathroom exhaust vents are going out the gables in this particular case instead of going up and through the roof. So we have the ability to put 26 solar panels on each one of these roofs now, whereas in the prior picture, we're going to be very limited and it's going to be very piecemeal as to how that solar is arranged. And one, that's going to increase the cost, but two, that's going to obviously decrease the amount of panels that we can get on that roof if we had to put solar on this house's roof here. So just good design goes back to sort of thinking through things with a critical eye, right? Where can you optimize for solar exposure? Where can you optimize for window placement? Where can you optimize for structural use here? And so here, this is just a red line drawing, a snip of a plan review that we did for another architect's plans that we were going to build, where we're trying to standardize window sizes. We're trying to standardize alignment of window openings so we minimize load paths in the pursuit of reducing our framing lumber costs and our framing labor costs along the way. And then we're getting rid of unnecessary windows that might not contribute to light and vent requirements or conflict with things on the inside of the floor plan or something like that. So again, this goes back to the integrated design team, making sure that you have a great relationship with the architect, a great relationship with the homeowner or your builder, however your organization is created, and that everybody can talk to each other and explain the whys for things as plan reviews change and change layouts and floor plans and features. So this is a great example, actually another house going up under construction near me where we have 4 different window sizes on one elevation here. So the framer has 4 different header configurations to make. These window heights are actually at 4 different header heights. Again, so increasing the complication for our framing labor to do this project. And the window sizes themselves are actually 4 different widths. And I understand the window on the left is a double window, but it's not a double of the single wide window that's up above it. And so again, these things sound silly and they sound small, but as you compound these small changes in framing efficiency, as you compound these small changes in labor for your framers or carpenters to frame the structure of your home, that increases your speed, that decreases your material waste, and ultimately that increases their profit, which hopefully they might consider splitting with you sometimes if you can make them go faster on a particular home and make them more profitable running their business. Plus, they're going to be around to be your partner in building later on down the line if you can make working for you be the builder, or developer, or homeowner of choice along the way. So this is something I would have certainly value engineered if I were a part of the project team on this, is to say, hey, can we standardize these in any ways? And I'm not an architect, let me please be clear about that. And so there might be very, very good architectural reasons for having 4 different window configurations and 4 different header heights on this elevation of the building. I just don't know what they are. I didn't walk through the floor plan and I didn't design it, but it's a good illustration of where those things might be. So I'm focusing mostly on the building envelope in this presentation because that's where I think a lot of the interest in the group that's on the call lies. But still, we have to design the exterior with a thought and a view towards the interior and the spaces that our homeowners and our clients actually live in, right? So I'm not going to focus a lot on interior finishes or interior value engineering like can light layouts or outlet layouts and condensing outlets on the walls or spacing of outlets or things like that. But those are very important things. But needless to say, we still need to make homes that are livable and comfortable and look great on the inside as well as are functional, right, and are cost effective to build on the outside. And I think only by doing that do you find the medium where you don't have a windowless box, which would be super energy efficient because there's no window and door penetrations, but also super terrible to live in, kind of like a prison cell. So there's a balance that we need to find between having those punch penetrations in walls, or even skylights and roofs, and the livability of the space to make sure that it's awesome, has a ton of natural light, and people want to buy the house that you built for them. These are some great examples of what I might call questionable design. And please, again, I'm not an architect, but these I think are less desirable houses to live in. And I put these up on the screen because it doesn't matter how energy efficient these homes are. It doesn't matter how much solar is on these roofs. It doesn't matter how good the indoor air quality is or how durable the building envelope is, that they're never going to have mold or mildew. I think arguably most real estate professionals would have a hard time selling these two homes in most cases. So again, there's a compromise here between high design, good design, marketable design, and high performance buildings. And it's all about finding your niche in your market to make sure you do that. Specification wise, once we design that set of plans and come up with floor plans that work and elevations that work and good southern exposures and lots of natural light, we got to make sure that it's all specified properly because the plans can only do so much. And so we always follow up our set of architectural plans, whether or not we drew them or have a partner architect or a client's architect draw them. We always want to have a supplement of a ton of written specifications that go along with those plans. And normally those written specifications are in a binder that gets distributed in a PDF, honestly, electronically to all of our subcontractors, but also put into a binder and kept on site. So somebody has a question about a faucet specification, or somebody has a question about a detail on our plans, or a floor joist layout, or a specific insulation strategy, or a way to flash penetrations for an HVAC line set or something. There's a detail for that, and there's some notes about that, and there's the material that you should use, all in that specification book that's always easy to have on site. And this works for production home builders, right? I used to do that. This works for semi-custom and custom home builders. This even works for owner builders who are doing projects that are zero energy ready to sort of think ahead and think about what obstacles your plumber or your HVAC contractor or your electrician or your framer are going to come across and try to solve them for them before they run into them on site and just decide to solve it on the fly. So again, that goes back to that proper planning prevents poor performance idea. This is just another detail that's in one of our typical specifications for how we do basement foundation flashing here. This was drawn in SketchUp because a 2D section view doesn't have this amount of detail and it isn't really color coded. So we found details like this where this did cost quite a bit of time to design, right? Is extremely helpful in illustrating how everything is lapped, what materials are here, and how those all interact, as opposed to a black and white small section diagram that's typically found on a set of architectural plans. All right, so all of those things are great talking about design, but ultimately we got to figure out how much it costs to build it, and we've got to keep the cost down, right? And those topics that I just talked about, I think do relate to keeping the cost down, but they relate to keeping the cost down in the holistic way, right? If you don't need a 4-foot wide window when a 3-foot wide window will do and will match the other windows on the elevation, let's design in from the beginning a 3-foot wide window so we're not taking away a foot of window from a client, right, during the post-design phase or the budgeting phase. If we're talking about aligning windows together where we can, let's do that in the design phase and save the money on structure and save the money on framing, labor, and material, so we don't have to talk about that in the budget phase when we're over budget. Right? These things can be built in, so they almost become non-negotiable. That's not really the right word, but I think it's the right meaning, that they're baked in from the beginning, and you've sort of baked in that cost savings there. So you might be able to spend more money on things later on, or so you might hit your budget target for building the home overall. So, all right, cost versus value, I guess, let's say, or cost versus efficiency. Can be really, really, really difficult to calculate. This is not a cost versus efficiency graph, but this is, I think, how some builders or some architects or some clients approach trying to figure out what the cost benefit is for certain things. And I'd argue that it's hopefully much more simple than that. Ideally, the cost benefit of things is pretty linear. right? If you choose to have triple pane windows versus quad pane windows versus double pane windows versus no window, right? Hopefully you fall somewhere on this line of cost benefit. But what I found over time is that the cost benefit relationship is truly not linear like this. It really is more of a curve or a hockey stick sort of. And that with some little things, right, little design changes, like I talked about, alignments and orientations and building material selection, you get a lot of benefit, or you can get a lot of benefit without a lot of added cost. And once you start increasing benefit beyond a certain point, your cost starts to go up on a stronger curve, right, as you go up the hockey stick here on this graph. And so I would roughly equate it to the overall program requirements that you have for above code building programs. So at the very bottom on the lower left corner of this, it's going to jail, right? Because theoretically, if you build a home not to code, you're breaking the law and you go to jail, right? That doesn't happen, unfortunately, or fortunately, I guess, along the way, but it could theoretically. So let's say jail. Nobody wants to go to jail. So let's build the code. Okay, we built the code. We're not going to jail. How do we build above code? Generally, the programs in the U.S. at least, they go up in this direction. So Energy Star is the next level to say, hey, a lot of production builders are building Energy Star. A lot of private home builders are building Energy Star because the bar is pretty low. The guidelines are pretty low, but it's still a better than code home, which is great. And it should have a sticker to say that this is better than the house next door. That's somebody's going to go to jail for building that. As you go up the hockey stick, you get Zero Energy Ready, and then you get PIS, the Passive House, Passive Institute, Living Building Challenge. And please forgive me, there are more programs than this, I know, but these are the programs that many people know about. And so these are the ones that I've put on here. I would argue, and this is probably the subject of much debate for architects and homeowners and builders, that this is true, that as you go to comply with the above code programs of Zero Energy Ready and Passive House and Living Building Challenge, your cost increases can begin to exceed your benefit or your perceived benefit or your actual measured benefit along the way. So we want to be careful about balancing those things and deciding, again, setting the expectations, where's the goalpost at the beginning? Are we going to hit Living Building Challenge or are we going to hit Energy Star? Well, here we're talking about hitting Zero Energy Ready, but any of the methods and any of the ideas that we have that I've talked about will matter for all of these programs, including staying out of jail, I'll say. All right, so that's, again, just highlighting the area where I feel is most effective and where you can get to with Zero Energy Ready, which is basically a lot better home with a little bit more cost. So the DOE has a much nicer graph. This is also available on the DOE's website, I believe, or maybe on Passive House's website, Passive House Institute's website. But this is a great example of what's necessary to get to each one of those steps as you go above code. And it even is sort of in my shape of the hockey stick, which is great. All right. We're going to start to move a little bit faster here as we go through some of these building materials, as we go through some of the ideas for value engineering, as we go through some of the advanced framing stuff. So try to keep up if you can and take notes and put some questions in the chat box if you need to along the way. All of the things that I'm going to talk about here for materials usage really should start the question of what is the first cost versus what is the total cost. And that goes to home building overall, right? As you're talking with a client or if you're a homeowner talking with an architect, if I spend more now, am I going to get more return later? And generally speaking, with Zero Energy Ready homes, the answer is absolutely yes, right? By spending a little more on insulation now, by spending a little more on advanced windows now, by spending a little more on air sealing, you're going to get a lot more in terms of energy savings, which is accurate, but also in comfort and durability of the home, whether or not that's pest resistance or air infiltration or moisture durability for mold and rot and mildew. All of that stuff comes along with spending a little bit more now. So the same question goes for building materials, for wall sheathing, right? We're talking about first cost versus total cost. I would argue that the first cost of zip sheathing or fluid applied membranes or liquid applied membranes is more, but there is a total cost benefit to doing that. Maybe it's a labor savings, maybe it's performance savings along the way. Exterior coatings run the gamut from, like I showed on there, which is a surface film with the zip wall, to fully adhered membranes. Either Blueskin, Grace makes a product like this, and many other manufacturers make a fully sticky, right, a peel and stick membrane that goes across the whole house. all the way to curtain products, right? Delta has this, which is not fully adhered, but it sort of is like smaller pieces of Tyvek or weather barrier. Plus, of course, Tyvek and all kinds of other home wrap manufacturers, Armax and Gator Wrap and whatever else is out there, Typar and all of that. No matter what, you can install any of these. And as you see, many of these homes look the same because I have installed all of these different weather barriers on various homes that I have built on the semi-custom side of my life, and tried to judge their cost versus performance. And I'm intentionally not sharing that cost versus performance data with you to reinforce my message from the beginning of the presentation, which is you need to do a little bit of research and understand what's important to you. If air leakage and air leakage alone is really important to you and you're willing to pay a lot more money for a little bit of a decimal point move in air leakage because you believe, or it's modeled, that your energy savings are going to make up for that difference, you should absolutely go with a more advanced product or a more durable product or something like that. But what I can say over time is that I've always come back to a properly installed Tyvek weather barrier on most of the homes that I have built or designed or specified. Because when properly installed, with seams taped and windows properly flashed, and cap nails properly used, our air changes per hour, our air infiltration rates were almost as low as a fully adhered membrane for blueskin. And again, this goes to a little bit more detailing, a little bit more care, but the numbers really are there. That said, if you install any weather barrier, a fully adhered weather barrier, a liquid applied weather barrier, a house good or a wrap weather barrier in an improper way, you get garbage results. So again, back to what I said later, you can use packaging tape like you get from the post office and try to use house wrap. You can reverse lap your house wrap and always get water infiltration here along the seam. You can completely improperly flash windows and make it look terrible. Again, this is not my house. I sneak into other job sites sometimes and take pictures of bad things and then have conversations with the GCs and the installers about their stuff. You can not counter flash, right, and not reverse flash and just dump all the water into bay window assemblies instead of tucking pins under and properly detailing things. And I don't even know what's going on here. There's some zip tape on this. There's a couple different kinds of house wrap. There's one window that's half flashed and not the other. But ultimately, this goes down to read the manual. So read the manual and install things properly, and magic things happen. You get great air leakage performance, you get great insulation value, you get happy homeowners, and you get low utility bills if you just read the manual. And whether or not that's the manufacturer's manual or that's the specification doc that you've put together with the architect or with the homeowner, with your GC, it all goes back to just properly installing whatever material you chose to buy. And that is going to get you the best value rather than necessarily upgrading the material that you choose to buy for your exterior building envelope. So these costs are not real that are on the lower left side of the screen, but they are general ideas and points of conversation. So I could go and spend $2,000 for OSB and Tyvek on just material, but then my labor cost is probably increased because I have to go back around the house and install Tyvek and flash all the windows maybe once the walls are all erected. Or I could spend a little bit more money on zip sheeting, and I have one less go around the house to wrap up the house, but I do have a higher material cost. Or I could spend more money on blueskin and have a little bit of increased labor cost, but my air leakage number might be lower by 0.6 of an air change per hour or something. And again, this goes back to you asking yourself, where do you want to spend the money? What's important to you in this, I guess, paradigm of different costs and total costs for material and labor together. Windows are the same thing, right? You can get triple pane windows super cheap that are vinyl frame. You can get triple pane windows that are fiberglass or composite frame. You can get triple pane windows that are wood frame with aluminum capping or imported wood or whatever it might be. Where do you want to spend the money and where's the value to you? Can you do high performance building with triple pane or quad pane tilt turn windows affordably? Yes, but you can't necessarily do that if you get imported walnut that's stained purple, right? Or I don't know, whatever it might be. Just sort of an example there. Mechanical systems follows the same idea, all right? Really evaluating the project, working with a mechanical system designer if you can, and seeing what the right system is for you. I've done gas systems. This is a natural gas system here. I've done a propane system, but more recently I've switched to completely all electric. homes, both for my semi-custom and production and modular home building companies. And what I found is, and what you probably have heard repeated over and over again, is that the building envelope matters first, right? We need to make the building envelope extremely tight, very well insulated, and choose proper materials for that so we can have a very efficient, small mechanical system. And once you make a very tight building envelope that has low air infiltration, then you can go to some of the smaller systems, whether or not that's a split system or a serve system or a combined system or something like that. And you get the benefit of being able to have smaller mechanical equipment purchase price, but potentially smaller mechanical equipment distribution as well for ductwork that goes through ceilings or walls or things like that. Whole house ventilation, there's ways to skin this cat too, right? In central controlled systems versus exhaust only versus balanced systems. But again, you have to make sure to balance the first cost versus the total cost. I can go out to buy an air cycler system or a Honeywell system, which is a return air tide system when you have a forced air blower that goes throughout the house, which integrates with the blower and can run it. But really, you need a blower that can run at a variable speed. And then you also need to have control wiring for some sort of exhaust if you choose to do that up to a Panasonic fan or something where you're connecting those things, right? So maybe you have an increased mechanical cost to do that. Maybe you have an increased electrical cost to do that, to run that control wire or that linkage. And maybe you have an increased level of maintenance on the homeowner to make sure that that linkage works in the long term. Or I could spend $1,500 and get a self-contained system as an ERV or an HRV and install that and have it be separate from my mechanical system overall. Again, these are options and ideas and thoughts that you should think through as you're doing the mechanical design for projects that you work on. Is where do you need to spend the money and how much do you need to spend overall? Insulation, this one I would actually argue and share and argue that there's not much of a place for fiberglass insulation in high-performance homes. Fiberglass batt insulation in high-performance homes. The cost difference here in the Chicago market anyway between a blown fiberglass or a blown cellulose product and a batt fiberglass product is relatively small in the overall cost of a building. And it is just too easy to improperly install fiberglass batt insulation, in my opinion. Other people have different opinions, and that's fine, but this is a great example of something that is pretty inconsequential, it might seem, but you wind up having convective loops, and you could have comfort issues. This is in an attached garage, which is a whole separate conversation, with a utility room wall on the back side of it. So right here, we have connections to the outside and air circulation and not great things going on. No matter what insulation strategy you use, right, you got to make sure to have air barriers properly aligned. And that goes back to doing the pen test, right, on your architectural plans in the building section. Where is my air barrier as I go around the 6 sides of this building? 4 sides of the building when it's in 2D on your page. But where's the air barrier? Here, we're completely missing an air barrier in what will be a bench seat in a shower area. So this is an air leakage issue. I guarantee that that's not spray foamed behind there, and we don't have a prevention of air from getting into that cavity, especially in a very, very moist area like this in a bathroom setting. Not a great thing for building durability. That is back cellulose insulation, blown fiberglass insulation, wet blown cellulose, dry cellulose with bibs. All these things are great solutions. They yield really, really good coverage. And they look really nice, honestly, if you're doing a walkthrough with your homeowner to go through and do it. Don't forget that air sealing is still very important, regardless of the insulation strategy you use, right? You lose more energy versus convective air movement than conductive heat transfer. I think my building science terms there are correct. So no matter how much insulation we put into a wall, we want to make sure that our exterior air barrier is very, very well done. We want to make sure that our interior air barrier, if that's part of the building envelope design, is also effectively done. And in this case, that could mean sealing sill plates. That could mean sealing and gasketing around electrical or low voltage outlets. That could mean making sure that rim joists and ceiling assemblies are properly sealed and spray foamed and tied into that red line, right, that we're drawing around our building envelope as we go across. Wall insulation spray foam is absolutely an option. You just need to make sure that the spray foam contractor that you have is good at what he or she does, and they don't give you a product like this, which winds up needing to be trimmed and shaved, and you still have voids in the cavity and all kinds of other things. So spray foam is a little bit harder to do because you're mixing 2 components normally, and those 2 components can be reactive at different rates depending on temperature and gun mixture and pressure. And so make sure you choose a reputable spray foam contractor if this is the route that you choose to go. I'll talk quickly about foundation installation. Please don't do this no matter what you do. Our strategy in the Chicago area, for the most part, is to use exterior foundation insulation that's protected with an aluminum cap on the outside. That way we don't have to finish the interior. We have basements in the Chicago area a lot, so we're not finishing the interior walls, and we're not having to deal with flame spread or smoke developed indexes or anything like that for exposed insulation on the inside. So we have bare concrete walls for most of our homes and basements because our insulation is all on the outside. But if you do the insulation on the outside and you do this, so you can have the grade go right into the insulation, you're ultimately going to wind up with a band of heat loss right throughout the entire perimeter of the house. And if you go back to this house in the winter with infrared camera, it's just going to be this line of red around the whole house where they're sucking hot air essentially out of their home in the winter, which is terrible. Bad disservice. You can use rock wool insulation for this. You can use foam insulation for this. Just a tip, if you do wind up using foam insulation for this, please make sure that you figure out how you're going to cap it on the outside. And so one of our design items here is that we're always tapering the foam insulation so we don't have a shelf where water buildup can accumulate and sneak back underneath the sill plate that would be mounted on top of the foundation here. This also provides for a little bit of aesthetic differentiation on the outside where you have sort of a sloped surface of metal capping or aluminum capping instead of just a flat shelf that looks kind of funny when we first designed it. Other ways for cost effectively building, right? And again, this doesn't go back specifically to zero energy ready, but this goes back to building more effectively by using less material, is advanced framing. And so here we're using insulated headers that are smaller. So we're one, using less material, but two, we're using more energy efficient material because we have a sandwich header with structural members on the inside and the outside, and then foam insulation to act as a thermal break in the middle. Or on the right side, you could have 6, it looks like, top sills on that, and then a giant 2x12 header for not much of a load. Sorry, that's probably a triple 2x12 header for not much of a load on top of that. So again, please be careful with your framing and with your framing contractor, he or she, to go through some details like this and think about getting these details in that specification guide that I mentioned, the binder, having on site for your framing contractor. I won't go into depth anymore about advanced framing. There's whole presentations about that from everybody on YouTube, from the Department of Energy, from Building America. Please go and watch an advanced framing presentation and save 20% on your lumber costs and make your framer's life easier, and just make a better building as well with more insulation. I will real quick talk about something that not a lot of people I've seen do. It's a staggered stud wall assembly where we have a 2x6 or a 2x8 top and bottom plate and then framing around windows and doors and things like that. But we actually have 2x4 studs staggered at 12 inches on center, inside and outside, which ultimately leads to an interior spacing for drywall attachment of 24 inches on center, or an exterior sheathing attachment of 24 inches on center also. This gives you that integrated thermal break in the building envelope without having to do exterior insulation. So depending on your climate zone, if you're in climate zone 5 or 4, climate zones where you have to do 2 inches or more of insulation, you get into the trouble of having to do furring strips or a full nailable base, like a zip bar sheathing or something. This sort of prevents that by just having that nail base be on the outside of the staggered stud wall and then have your gypsum be there with the thermal break integrated. This is what it looks like in reality for framing. You can sort of see that insulation, again, our blown cellulose insulation would sort of serpentine through that. And you would only see every other stud when you look at it from the inside because the other stud would be covered with 2 inches of insulation, or if you use a 2x8 plate, even more insulation than that. Other things about reading the manual and just proper design, right, is proper mechanical system design to get a high performance home is just doing things properly, right? If we can minimize duct runs, if we can be efficient in how we're distributing HVAC airflow, and make sure that everything is mass fixed or taped, and that there's no extra kinks or no 90 degrees coming off of exhaust fans like this, they're going to lead to poor performance. That's certainly something we want to focus on as well. And it sounds stupid, but this should be a detail in that specifications guide as to how your HVAC subcontractor or you are going to run your exhaust duct for your bathroom fan. Think about it. Is it going to go out the south-facing roof plane and interrupt your solar panels? Is it going to go out the north-facing roof and then be a potential roof leak? Is it going to go out the gable where you can probably properly flash it like a window or a door and have much better long-term performance as long as it goes straight out? all those kinds of things. Plus also, generally requirements for bathroom fans is that they have a minimum distance to accumulate static pressure before you have a 90-degree fitting. So this is a totally wrong installation of this bathroom fan on the right side there. Not a great thing. All right, holy cow, I'm talking slow or fast. We've got about 4 minutes left in that 45-minute window that I gave myself to talk through these last couple things, and that is talking about design for value engineering when you're doing multiple projects. And that could be the same house over and over again, or that could be similar homes with the same ideas and the same methods, just with different floor plans or layouts or finishes. I've always been a big believer in the Toyota manufacturing philosophy, or I guess more the Japanese manufacturing philosophy is Kaizen, which is continuous incremental improvement over time. And so if you change 10 little things along the way, you wind up really, really far from where you started in a positive way without making a whole big sea change all at one time, right? It's sort of the positive version of death by 1,000 paper cuts. It's growth by 1,000 changes along the way. So continuous improvement could be figuring out a better way to flash a penetration in a house, or it could be figuring out a standardized window assembly on this house. So on the next house, you can figure out a standardized flashing detail or change your flashing membrane or something, right? But each house, I challenge you, if you're not a homeowner who's not doing this for a career, is building that next home a little bit better each time in one way or another. And then honestly, taking stock at some point every year, every 6 months, every 2 years to look back and say, here's what I've changed over time. It doesn't feel like I've changed a lot, but when I look at my air changes per hour number, or when I look at my total homeowner utility bills, you can see that change that you've made by those small incremental changes that you've implemented. We already went over those details. I'll skip this. We do, as part of our standard detail, we do a wall sheathing layout and a Tyvek system layout as well to make sure our framers are cutting things and measuring things properly. I'll talk for a second, about one of the things that people always ask me is that if manufacturing and offsite and modular home building is the savior of this industry, is it any more cost effective? And I would challenge, yes, is the answer. Overall, again, when you look at total cost. So Kinexx Modular right now in Chicago, as I said, we build modular homes in a factory, and then we ship those components out to site. So our first cost and our level of quality is definitely higher than many stick-built, site-built contractors, many. I'm not saying all. There are certainly some contractors out there who are doing great jobs out in the field. But in Chicago, you're subject to the snow, and you're subject to the wind, and you're subject to the rain and everything else, the hot weather now that we have today. That just degrades the building, the labor, I guess, that would be putting the building together. So building in the factory sounds like the godsend to fix everything. But our material costs are probably about the same, and our labor costs are probably about the same. There may be a little bit less because we were more efficient in our material and labor usage. And we can build a lot of modules at one time, right, and stage them and have them all ready to go. And do things like insulate roof assemblies before they're put on and properly do all this. We can do many things as a modular manufacturer, but ultimately we then have an increased cost in our site logistics and mobilization. And so what money that we save in terms of efficiency on labor or on building materials or on bulk volume, because we at Kinexx are also the general contractor in many cases, we're responsible for the erection of the modules on site, and we have to pay for a big crane. We have to pay to truck those modules out to site, and we have to pay for a street closure permit, right? Sometimes to have that crane sit on the street to do this. And so the first cost of the material and labor to put together the modules seems very attractive, but the total cost of delivering a completed shell to site is probably pretty close to cost parity for us, at least in our business model, with stick building on site. The value is the increased level of quality, the reduced amount of waste, and the increase in speed that you get with going from a foundation that's empty at 7 a.m. to a foundation that has a house that's completely weather tight on it by 2 p.m., which is exactly what's happening today in Chicago, where Kinexx is doing a delivery. So again, just reinforcing the conversation around total cost versus initial cost. So let's wrap it up and sort of tie it all together. How do we get to build high performance, award-winning, zero energy ready homes in this market? And that is through a lot of little things, right? There's no magic bullet that does this. Again, this is not a recipe. You have to take into account these things that we talked about at the very beginning for planning. Planning will save you a lot of money. It will make your homeowners happier. It will make you happier if you are a homeowner. It will lower your utility costs. But again, you have to make that investment up front in terms of extra dollars spent or extra design costs or extra architecture fees or extra time to create that specification manual to see that result in the end, or to have your homeowner or client see that result in the end as well. I hope I've proven along the way here that off-the-shelf materials can work, right? Standard Tyvek, right? Standard vinyl frame windows, fiberglass blown insulation, loose blown or cellulose insulation. We don't necessarily have to spray foam things. And also you need to remember about, again, that cost benefit, that hockey stick, right? Where's the goalpost that you're trying to get to? How much do you want to spend to get there? And when are you going to be happy cutting off your efforts and saying, I achieved this, I don't need to go all the way up here, or I don't want to go to jail on the bottom side of that. So I will talk for a second about cost here, but only to say, talking about square foot cost, it's kind of a crazy thing to do. A lot of times builders and homeowners and architects are talking about square foot cost, and we're not talking on the same page at all. For a house, right, a random house, 3,000 square feet maybe, there's all kinds of different square footage numbers that you can assign to that, whether or not it's stick built or built as a modular house. You don't know if site development's in there, storm water connections, permitting, architecture fees. You don't know if site finishing is in there, or you don't know if they have a gold-plated toilet. But also, you just don't know what the divisor, the bottom number that we're dividing by is, right? Is it above grade square footage? In Chicago, we have basements, right? So is it total condition square footage, where we have another level below? Is it usable square footage that doesn't count the stairway spaces or the attic spaces or things like that? And that number changes tremendously. So please, if I could ask one thing coming out of this presentation, is not to talk with clients, or not as a homeowner, if you are, to ask about cost per square foot, and sort of go back and talk about the value and the total build costs and where all of the costs are going to fall into place around that. Again, this goes to the first part that I talked about, which was what's included, right? Is it the structure? Is it the shell? Is it finishes? Is it land? Is it architecture? Is it permitting? Those things also change this dollar cost tremendously. And I don't think anybody ever talks on the same page about those things. The last thing that I'll say here is that please, no matter what we're doing, don't forget that we are building the homes that we're building for families, for people to actually live in them. And assuming you're not a homeowner yourself building your own home, but spending a little bit more money on that building envelope, or being more vocal to a client to say, hey, I think in my professional experience, you should do this because it's going to make you more comfortable in the long term, even though it costs a little bit more now, is a conversation worth having. And I know that we've got difficult clients, and I know that we have clients that sometimes just want their granite countertops or their gold-plated toilet. But man, if we as building performance professionals can impart the knowledge of the long-term benefit of a little bit more money spent on building envelope and building performance and above code building third-party certifications, then we will grow this, and maybe in 5 years I won't have to make this presentation again to another group of builders. So with that, I will turn it back over to Mike for any Q&A stuff that I can answer along the way. I can cycle back through slides that come through here. I might be able to pull up some other pictures or just talk about things in general. Mike?
Very cool. And, your commentary there at the end about the price per square footage reminded me a little bit of talking about that exact topic with Ron Jones. And his comment was always, why do we price homes like we price meat? Yeah, there's definitely a variance in the value of some of the square footage, closet versus bathroom and so on and so forth. So I appreciate you hitting on that point. And yeah, if you do have questions for Scott, please go ahead and send them in. We do have a couple already to get to, Scott. So Zoran is one of our Housing 2.0 attendees, just most recent alumni. And he had a couple questions. I'll get to one of them now, and that is, when you're doing net zero energy homes, is it pretty standard to use triple pane windows?
So again, in our climate zone, outside of Chicago, climate zone 5 or 5A, we are using triple pane windows. That's what our energy model has worked best at doing. And honestly, we can get pretty affordable vinyl frame triple pane windows in our market. So yes, every single home that we build has triple pane windows. Sometimes it's upgraded if we have a custom client who wants aluminum frames or clad wood frames or something, but we're always doing triple pane at a minimum here.
Okay, very good. Had a question come in from Dave. You were giving some opinions earlier, so we've got a couple of opinion questions now for Scott to speak freely on. Dave wanted to know what your opinion is on Timber HP insulation products.
Dave, I am sorry. I have no opinion on Timber HP insulation. I have no awareness or product knowledge of that, and I cannot articulately or in any educated way speak about it. I am sorry. I will look into it now, though, because actually I love learning about new building materials and approaches. So it's going down for me to research.
All right, very good. Another opinion question from Zoran. He wanted to know where do you stand on ICFs, insulated concrete forms?
Insulated concrete forms in the right location, in the right building assembly are great. We have used insulated concrete forms in some of our foundation systems before because that was an architect specification. We've seen them used. They're great for different markets, I guess I would say. But in the Chicago metro area, in the suburbs of Chicago, our concrete foundation subcontractor labor pool is pretty built out and pretty competitive. And so we find that there's absolutely no cost savings for insulated concrete forms, ICS, in terms of labor, even though we have to erect and strip footing forms. Our foundation subs are just so fast at doing that because they've been doing that for 40 years, or however long it's been. But then also, as I mentioned in the presentation, we have the increased cost of making sure that foam insulation is flame or smoke developed index protected on the inside, right? It has to have some sort of ignition barrier in most of the municipalities that we work in because we're doing full basements. And so in the case of a homeowner who doesn't want to finish their basement right away, or in the case of just competing on a cost per square foot basis, we find that we're adding on the cost to drywall all the walls. And then once you drywall the walls, it looks kind of funky if you don't drywall the ceiling in a basement. And so the cost benefit there hasn't been worth it for us in that respect either because of the fire protection that has to go on there.
Right. And I'm curious, you brought up stripping the forms, and we're talking about basement walls. How long do you tell your basement contractor, if this is a specification, I'm not sure, but how long do you tell them to leave the forms up for curing those walls?
The proper amount of time that is required is the gist, right? So in Chicago right now, it's 90 degrees, it's pretty sunny, and so we might leave forms on, or the concrete subcontractor might typically leave forms on for a day, and that's it. And if we're building a 4 foot tall, right? You can see this house in the picture in the background has only a 4 foot deep foundation. And so the thickness of the concrete is probably 8 inches, and our unbalanced backfill is probably only like 3.5 feet, maybe 4 feet. Those forms can certainly get stripped faster than a 12-inch thick wall that's got 8 foot of unbalanced backfill that's going to be pushed against it when we do backfill. So I would say it varies based on climate, right, and weather, right? In the winter, obviously, we're leaving forms on longer, but also varies based on your backfill conditions and your soil and that kind of stuff here. So for an 8 foot foundation wall where we have a 10-inch thick wall and we're backfilling with stone and clay, just spoils from site, we're probably leaving those forms on for 3 or 4 days, and then doing groundworks while the wall continues to cure before we even do any backfill work with the foundation floor system installed.
Okay, all right. A couple questions came in from Cheryl. We'll take them one at a time. She wanted to know first, have you ever used a triple pane window with a film as the third pane?
We have not. I've looked into that. We as a team have looked into that. We just haven't been convinced and sold on it. And that could be past experience with thin films, right, from probably 20 years ago now, that had lots of manufacturing and performance problems and failures. It could also be just that our vinyl frame windows have a thin enough glass profile and a thin enough spacer profile that manufacturing is pretty typical. The cost is pretty competitive, and there's not a compelling reason for us to jump to thin film for the third, so they integrate the center pane instead of 3 true glass panes throughout the way. I'm not saying it's a bad thing, not saying you shouldn't do it. Again, it depends on your market. If you have a window supplier that's got great pricing and performance on thin film, absolutely, check it out. Here, it hasn't been a concern for us to stick with 3 panes of glass.
Okay. And then continuing on with that, are there any manufacturers that you like best if you're comfortable talking about manufacturers?
For Windows, is that the question,
Yeah.
Mike?
Yeah.
I mean,
follow up of the triple pane with film, but the triple pane window. Yeah.
Sure. I will absolutely plug Okna Windows. I think they're out of Philadelphia or Pittsburgh for really cost-effective vinyl triple pane windows. I don't know where they ship. I don't know if they go west of the Mississippi, but I can say that we have had great performance with very few seal failures on our Okna windows, and their profiles, again, vinyl having the negative connotation of being cheap windows. We don't have that with the profiles and with the construction methods for Okna windows. Are there other manufacturers that make really high performance, good looking vinyl windows? Absolutely. But we just have chosen not to change what is working really well for us on many of the housing types that we're building. In Chicago, we have another manufacturer, Climate Guard, that's local to Chicago. They have a factory right here in the Chicago metro area, and they do a lot of our windows as well. Same thing, vinyl, double and triple pane windows from them. Beyond that, we have looked, and I have used for semi-custom and custom projects where architects or clients specify Pella Series windows or Anderson Series windows. We've done Sierra Pacific windows, and I don't have bad things to say about most window manufacturers. I have bad things to say about many window manufacturers' cheap vinyl builder grade windows that look cheap, function poorly, and have an increased level of seal failure.
Yeah. We had a question come in from Kristen, and it's interesting because I don't know. I guess it depends on how far you're going with your projects, but it has to do with seismic and kind of high wind events. She was curious if you could share your thoughts on any adoption you're seeing of outer envelope resilience to address those both seismic and high wind events, especially if you're looking at like adhesives versus mechanical straps.
Absolutely. So seismic is not necessarily a concern. Let me see if I can get to this slide here for us in the Chicago area. But we do have tornadoes, right? And we do have high winds. And there's certainly wind design ratings that we have to deal with. One of the ways, and this is just for stick framing, and I can talk about modular manufacturing in a second. But for stick framing, for us at least, we have our fully sheathed wall assembly, right, with a structural OSB sheathing, structure grade 1, which is the Huber zip system. And our structural layout is normally designed to span band joists and rim joists and to tie in without the need for hurricane straps up in the top here into a raised energy heel truss where we can do that. And so you have a full connection from the sill plate all the way up to the top without platform framing joints where you would need to do exterior strapping. I can't answer as to how that complies seismically with those code programs, right, in California or in Washington or Seattle or things like that. But I can say that this works very effectively for here, and drywall cracking for us, even in high winds, is almost non-existent because of the shear wall design, having a fully sheathed system and spanning and overlapping these joints that come along here. Real quickly, for modular, our modular system is also made to tie into the foundation with stirrups or straps, and then the modules are tied together essentially at all four corners with the modules that are next to them or above them or below them. So when we are done with a modular assembly system, if we have 8 of these boxes or 10 of these boxes or 4 of these boxes, They're all completely tied together as a single structural system, both outside and on the inside, before the finishing is done for the exterior and interior.
All right. Question coming in from Brenda, and I'm going to put out the final call for questions to our audience. Brenda wanted to know, has this really been market value tested? Like, what kind of a premium is given to properties that have efficiency materials compared to conventional building?
Brenda, that is a great question, and that is absolutely market by market. Can I say that the homes that I have built have sold for 15% more than the house next door that is conventionally built or crappy or leaky or anything? The answer is no, absolutely not. As a matter of fact, we have had a lot of problems with appraisal values and with our build costs for custom clients exceeding those for comps in the area because of the advanced building practices that we're using. And that's not to say that our building practices by themselves are just more expensive, right? Using cellulose instead of fiberglass bats, or using zip wall instead of OSB and Tyvek, right? Or those kinds of things. But just the overall cost of the home, once you factor in all those things with the increased insulation, triple pane windows or tilt and turn windows, foundation insulation, better air sealing, better project management, better quality, a house should cost more. Just plain and simple, it should cost more. Building a more energy efficient home doesn't cost less at the beginning, the first cost, right? It costs less over time for total cost of ownership. And so can you make that argument with appraisers sometimes about total cost of ownership for utility bills and durability? Yeah, but it depends on the appraiser, depends on the comps, and depends on the bank. Do people pay more for high performance homes? Absolutely, when they understand the benefits and when you're selling to the right consumer for it, right? They can make the math calculation about just straight dollar cost, right, of utilities over time, first cost versus total cost. But they can also, if you have a reputation or if you have an award, or if you're able to walk them through some of your homes in the winter or in the summer, just understanding the level of comfort difference that is perceptible, absolutely 100% perceptible in a zero energy ready, high performance, highly insulated, great building envelope home versus a code built home with that level of insulation and an air sealing and double pane windows and that kind of stuff. So I think I've answered your question, Brenda. If I haven't, hit Mike back with a follow-up, but I hope that does explain it. There is a cost premium. People are willing to pay more. Getting the money for it and from an appraiser or bank is sometimes a fight, is the summary.
Well, let's stay with that for just a moment, that topic, the financial topic, for just a moment, Scott, because Vanessa wanted to know, first of all, are green appraisals going to consider PERS in the future? I thought that green appraisals already were considering PERS in the list of things that they look at, right?
Yeah, it's market by market for sure, Mike, right? You might have just no comps, right? That there's no demand for a green appraisal. So all of a sudden you stick a green appraisal in front of a lender or in front of a bank or in front of a homeowner and they have no idea what it is. And there's some areas where it's sort of expected that the green appraisal is with the documents on the MLS, right? The supplementary documents that go there. Sandra Adamatis has been great about pushing this in the Appraisal Institute and pushing this for realtors and doing that kind of stuff. And we typically go so far as to do that green appraisal and provide all the checklists and everything that we can up front in that specification package. So we're having less of a hurdle for the appraiser to get over to say, I don't know what this is, or I don't know what it looks like, or I don't know how I'm supposed to fill it out. Do they have to take their blank form and fill it out themselves? Yes, absolutely, right? They can't just take ours and put it and say, this is the appraisal, ta-da, or this is the addendum to the appraisal. They have to do their own verification of these things. But we do that as a means to try to make them understand that it's actually kind of easy, and here's all the stuff that you need to know, and here's the data already for you. If you have clarifying questions, hit us up and we'll be happy to do stuff.
Okay. And then she also wanted you to kind of look into your crystal ball, if you can, Scott. She wants to know, will carbon accounting ever be considered?
Yeah, I would assume, just as we just talked about green appraisals, right? In some municipalities, there is mandatory energy bill reporting that goes along with used homes, and mandatory energy use disclosures to help new construction homeowners understand the total cost of their home instead of just principal, insurance, taxes, and mortgage, yeah, whatever, instead of just their PD amount. So can I see a future that has carbon accounting to it to take into account the energy use or the energy intensity of the construction of a new home? Absolutely. But it's certainly not going to be a national code standard. I think it's going to be adopted locally and slowly until it might have a groundswell to get to that point where it could be somehow integrated nationally by a standards board or somebody.
Okay. We're going to go back to a topic we were talking about earlier. We're talking about resiliency and that sort of thing, and you were showing the slide with the different wall views. Zoran wanted to know, how do you apply the wall sheathing that you were showing in that slide, and what is the cost associated to the extra labor?
Yep. Specifically then answering the question for Zoran, the wall sheathing is applied. Many of our homes are fairly straightforward to frame, and we use a platform framing method. This is stick-built wood frame. Kinexx Modular focuses exclusively on cold form steel framing, and so I'm not talking about our steel framing with our factory applied sheathing. I'm talking about stick framing in my past life, right? Doing structural wood sheathing on structural wood studs. That sheathing was applied as the wall was framed on the deck before the wall was tilted up. And so we can overhang the sheathing beyond the edge of the wall, so it goes down over the rim board if necessary, before that whole wall is stood up or tilted up, or depending on the thickness of that band that stretches between the floor system, the second floor walls, and the first floor walls, that can be applied later on as a 4-foot horizontal piece of sheathing or something like that. Do we account for the increased labor cost to do that? No, not necessarily, because for us in our market, full sheathing is standard, whether or not it's OSB or plywood or zip system. And so our labor cost to do full structural sheathing is the same. There is additional incremental cost for all of the zip taping, right, as part of the manufacturer's weather-resistant barrier system to properly do that and to roll that. But our framer has come to understand, the framer that we work with most often, that is, has come to understand that their labor savings in trying to manipulate rolls of Tyvek sometimes and tape seams across all the buildings and flashing is comparable, let's say, to zip panels. And so we don't have an increased labor cost for a full zip system versus an OSB and Tyvek system on the labor side, really. A total cost, I'm saying. Again, material plus labor, plus some transfer of air changes per hour and performance adjustment.
Okay. So, final question, Scott. I wrote this one down myself early in the presentation, and I was wanting to see if any of our audience members would ask or not, and did not. So I wanted to bring it up because it's been a fantastic presentation. Q&A has been great. You've gotten a lot of compliments from our audience. You have a variety of building perspectives. Can you talk about your preference for a prescriptive approach or a performance-based approach? And does it vary by circumstance, whether you're doing, modular versus, maybe a custom project or an infill or something? Like, can you talk about, because you highlighted before Zero Energy Ready, and you talked about the checklist that you use, and that's what kind of sparked the question in my mind. Do you have a preference for prescriptive versus performance-based?
My opinion is that performance-based codes and performance-based compliance with codes, whether or not it's above code or the base building code itself, is the real way to find the full value in terms of balancing cost trade-offs along the way in an integrated design for a given semi-custom or custom project. It provides the flexibility, right, because it's performance-based rather than following charts, right, and completely prescriptive. However, prescriptive is very, very, very helpful because you don't have to figure out what and how your mechanical system is going to integrate with your windows, which is going to integrate with your extra half inch of insulation in your attic. And then, oh, wait, now I need 1200 CFM of makeup air for my giant range hood or whatever, all those things, right? If you're just following the prescriptive code, you have an easier method if you're just starting off on compliance. I would take one more step and say that a better builder is probably using a performance compliance method because they're taking into account the overall building modeling, right? They're probably having manual JS&D done for the HVAC system. They're probably thinking about their fresh air ventilation strategy. They're probably thinking about their cost trade-offs for window fenestration and low E coatings or argon or or whatever it is, and taking all of that into account to make those trade-offs with the client when it comes to money and cost. And so I think you get a better building performance-wise. I think you get an easier building for a lower barrier to entry with a prescriptive-based code that's just following a checklist.
Gotcha. Well, thank you for that and all the insights you shared with us today. We really do appreciate it, Scott. And thank you also to our audience for attending, asking all those great questions, and obviously our sponsors, Schneider Electric, Panasonic Healthy Indoor Living Solutions, Jinko Solar, and LG HVAC. Thank you so much for your sponsorships. Now, if you like what you heard today, and I know that some of you did because you told me so, this is the kind of insight and knowledge that you can expect to get in the Housing 2.0 program. The Series 2 workshops are going to start on Thursday, October 17th. For more information and to register, please go to www.greenbuildermedia.com/housing-2.0. All right. Our next Thought Leader webinar is to take place on Wednesday, July 17th, at our usual start time of 2 p.m. Eastern Time. We're going to be talking about workforce housing and maybe a recent congressional appearance with Rob Howard of Howard Building Science. Scott, any final comments?
I do. I just wanted to add one thing. For the Housing 2.0, Sam Rashkin and the program that you guys have put together is phenomenal. I am a huge fan of his work for Energy Star program and Zero Energy Ready. A lot of what I talked about in my presentation comes off of some of the philosophy and concepts from Sam, the program, and the work that's been done. So thank you for putting those on, and I would highly recommend anybody interested in building better homes, check that out in much more detail, and grab the book if you can too along the way.
All right, now I got to get your address to send the check. No, I'm just kidding. That was completely unscripted and genuine, and we appreciate the compliment, Scott. We really do. And thank you again for being on the Thought Leader webinar today. All right. Don't forget, hey, this weekend is Father's Day. So whether you get him a tie or just send a card, I'm sure he'll appreciate the sentiment. Until next time, stay safe, stay healthy, and take care. So long, everyone.